Hey everyone, and welcome back to the channel. Have you ever stopped to think about the invisible forces that run our world? From kicking a soccer ball to launching a rocket into space, it all comes down to three fundamental rules. Today we are diving deep into the genius of Sir Isaac Newton and exploring how his three laws of motion are happening all around you right now. You might be surprised at how much physics you actually do every single day without even realizing it. So buckle up literally, as you'll soon see, and let's get moving. Let's start with Newton's first law, often called the law of inertia. It states that an object at rest will stay at rest, and an object in motion will stay in motion with the same speed and in the same direction, unless acted upon by an external force. Sounds a bit wordy, right? But think about this. You're a passenger in a car, cruising along smoothly. What happens when the driver suddenly slams on the brakes? You lurch forward. Why? Because your body, thanks to inertia, wants to keep moving forward at the same speed the car was going. The car stopped because of the force from the brakes, but your body didn't. That's why we wear seatbelts. The seatbelt provides the external force that stops you from continuing forward. It's a life-saving application of Newton's first law. The same principle applies when the car accelerates. When you're stopped at a red light and it turns green, the driver hits the gas and you feel pressed back into your seat. The car is moving forward, but your body's inertia wants to stay at rest. The seat pushing against your back is the force that gets you moving along with the car. It's not some mysterious force pulling you backward. It's just your body resisting a change in its state of motion. You can even see this with simpler things. If you place a coin on a piece of cardboard over a cup and quickly flick the cardboard away, the coin drops straight into the cup. The cardboard moved, but the coin's inertia kept it at rest, allowing gravity to pull it down. It's a classic, simple experiment that perfectly demonstrates this fundamental law. Now, let's move on to Newton's second law. This one is where math gets involved, but don't worry, the concept is super intuitive. The formula is force equals mass times acceleration, or F equals ma. In simple terms, this law tells us that the more force you apply to an object, the faster it will accelerate. It also tells us that for the same amount of force, a heavier object will accelerate more slowly than a lighter one. This law is literally the rulebook for every sport you've ever played or watched. Imagine you're playing baseball. To hit a home run, you need to hit the ball with a massive amount of force. A gentle tap won't do it. The harder you swing the bat, the more force you apply, the greater the ball's acceleration will be as it flies off the bat. Now let's think about mass, which is easier to push, an empty shopping cart or a full one? The full one, of course. Why? It has more mass to get the full cart moving at the same speed, or to give it the same acceleration as the empty one. You have to push much, much harder. You have to apply more force to overcome its greater mass. This relationship between force, mass, and acceleration is everywhere. It explains why a big truck takes longer to speed up and slow down than a small sports car, and why it takes more effort to throw a bowling ball than it does to throw a tennis ball. You use this law every day without thinking. When you're carrying groceries, you can feel the force required to lift a heavy bag of potatoes versus a light bag of chips. You're instinctively calculating F equals ma in your head to apply the right amount of force. When you're riding a bike and want to go faster, you pedal harder. More force from your legs leads to greater acceleration. It's the engine of motion, the direct link between our effort and the results we see. Simple, powerful, and constantly at play. Finally, we arrive at Newton's third law, and it's probably the most quoted. For every action, there is an equal and opposite reaction. This one can be a little tricky to wrap your head around at first, but it's the key to understanding how anything moves at all. Think about it. If you push on a wall, the wall is also pushing back on you with the exact same amount of force. You do and see the wall move because it has a huge mass and is anchored to the ground, but you can feel its force on your hand. A perfect example is a rocket launch. A rocket doesn't push against the air to go up. In fact, it works even better in the vacuum of space. The rocket expels hot gases downward with incredible force. That's the action. The reaction is that the gases push the rocket upward with an equal and opposite force. The rocket is literally pushing against its own fuel to lift off. Or how about swimming? When you swim, you push the water backward with your hands and feet. This is the action. The equal and opposite reaction is the water pushing you forward, propelling you through the pool. You are pushing the water, and the water is pushing you. Even just walking is a demonstration of Newton's third law. As you take a step, your foot pushes down and backward on the ground. The ground, in reaction, pushes up and forward on your foot. That forward push from the ground is what moves you forward. Without that reaction force from the ground, you'd just be slipping in place, like trying to walk on perfectly slick ice. The friction between your shoe and the ground allows for this action-reaction pair to work. So every step you take is a tiny, perfect dance with Newton's third law. So there you have it. Newton's 3 laws are not just abstract concepts in a physics textbook. They are the operating system of our physical reality. The first law explains why we need seatbelts. The second law dictates how we play sports and drive our cars. And the third law is the reason we can walk, swim, or even launch ourselves to the stars. The next time you're out and about, try to spot these laws in action. You'll see them everywhere, governing everything from the flutter of a leaf to the orbit of the planets. It's a beautiful system, and understanding it gives you a whole new appreciation for the world around us. Thank you so much for watching today. I hope this made physics a little less intimidating and a lot more interesting. If you enjoyed this video and learned something new, please give it a thumbs up and consider subscribing to the channel for more content just like this. Don't forget to hit that notification bell so you won't miss our next adventure. Let me know in the comments below which real-life example of Newton's laws is your favorite, or if you have another one to share. Until next time, stay curious.